Today I'm headed out to do water quality monitoring. So every 2 weeks we drive around the Ausable River watershed and measure the salt levels in the river to understand how the river is being impacted by winter road maintenance practices, both by the state and local DPW crews. So we're headed out to do that right now. Come on, Kyber. Up. So what I'm doing at each one of these locations along the Ausable River and its tributaries is using this multi-parameter probe, which is this thing here, to record temperature, dissolved oxygen, pH, and conductivity. And on the other end of the probe is this sonde, which has sensors that measures all of those parameters. The main thing that we're interested in when we're studying road salt is conductivity. So there's two little electrodes in there, separated from one another, and that measures the electrical resistance of the water flowing over the sensor. The more dissolved ions, or salt, in the water, the lower the resistance and the higher the conductivity. So right now I am almost right underneath this culvert under Route 73 at the bottom of Spruce Hill, where 9N meets 73 between Keene and Keene Valley. The brook running underneath the culvert and that you can see behind me is Norton Brook, and much of the runoff coming off of 9N down Spruce Hill, which receives a lot of road salt, flows in to Norton Brook here. So we're going to measure the conductivity of this brook to see how much salt is in the water. So we submerge the sonde end of the probe in the water, and we turn on the multi-parameter probe to get our measurements. And so the number we're looking at to understand road salt is this number right here. So it's 167.6 microsiemens per centimeter. A stream that does not have any roads in its watershed would have a conductivity of about 15 to 25 microsiemens per centimeter. So we can detect all of the salt running through Norton Brook coming off of Spruce Hill by looking at the electrical conductivity of the water in the brook. Okay, now I'm on Dipper Brook, which flows off the side of Rocky Peak and Giant Mountain, and it is one of our least impacted streams that we monitor as part of our efforts to understand road salt. So we would expect no additional amounts of salt in the stream here because there are no roads within its watershed. So it's a beautiful little brook. And that is Kyber, my dog, helping out with our field sampling. So it's mostly frozen over right now, but we do have a little bit of open water for us to get our sonde into and take a reading. So if we look at a screen of our multi-parameter probe, conductivity is 19 microsiemens per centimeter. So much lower than Norton Brook and within the range we would expect for a stream that is not impacted by road salt.